Okay, so we've already talked about in behavior. Now let's talk about turning points. And here's the key: is turning points are max and mins in a polynomial. It is always going to be one less than your highest exponent, and it's a possibility. And what that means is if I have x to the fifth plus 3x plus 1, there is a possibility that there are 4 turning points here. It's not necessary that there will be, but there's a possibility. So that really helps us out a lot. If we looked at our in behavior, this kind of tells us how I was able to graph it. So let's take our couple things that we know. So we're going to do x to the third plus 3x plus 1. And we'll do a higher number. Let's do x to the sixth plus x to the fourth plus 2. And let's go step by step on how this works. So we know for our in behavior that as x approaches negative infinity, that y approaches negative infinity. So it goes right here. And then as x approaches positive infinity, y approaches positive infinity. And in this case, so this is an even power. It's positive. So as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches positive infinity. So we know that. So those are our ending behaviors right now. Now, in our mind, x cubed. So how many turning points are there? There's going to be 2 turning points because it's 3 minus 2. That's all we know right now. So we can go 1 turning point, 2 turning points, and up. How many is it going to be? It's going to be 5. So here we go. 1, 2, 3, 4, 5, and up. Pretty simple. Another one. We're going to make a really big one. So let's do x to the 10th plus x to the 5th plus x cubed plus 4. Okay. So this is a power of 10. In this case, how many possible turning points are there? Well, we take 10 minus 1, and that's going to give us a 9. That's an even polynomial, so we know that our ending behavior is as x approaches negative infinity, that y does positive infinity, and as x approaches positive infinity, y goes to positive infinity as well. And we need 9 turning points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and the general idea of what is going on. Alright, so let's add something else to this. So we know our in behavior, we know how many turning points. So now we're going to talk about what our y-intercept is. So our y-intercept, if we remember from hopefully earlier lessons, is that a y-intercept is when x is equal to 0, what is y? And that gives us a coordinate point, something like that. Okay, we're gonna do a couple. So x cubed plus x squared minus 1. Well, when this is 0, so it's 0 cubed plus 0 squared minus 1. Well, that's 0 plus 0 minus 1. So that means y is, finish that up, -1 equals y. So So that means when x is 0, y is negative 1. Now why is that important? So watch this. So now we know multiple things. We know that our x cubed, it's a cube, so it's an odd. So that means that this goes right there. Our end behavior is right here. Okay, now, we also know that because of this, that it has to go through 0, negative 1. So it has to go somewhere about right here. So that means that during our trip, 1, 2, 3, that has to work. Again, we don't know a ton, but we do know at least that it goes right there. Okay, that's all we know. Now let's do a couple more examples. X to the fifth plus x to the fourth plus 3x. What is that? Okay, so what happens when x is equal to 0 here? Well, if that's the case, then that means y is going to be equal to 0, so it's actually going to go through the origin point. Again, our ending behavior is down here. And it's up here, right? Because as x approaches negative infinity, y goes to negative infinity. And as x approaches positive infinity, y goes to positive infinity. It has to pass through the origin. It takes 4 turns. Again, the 4 turns can end up anywhere as long as your path goes through 0, 0. That's all we know right now. So we're going to go 1, 2, 3, 4, and up. Pretty simple. Let's do another one. This time, let's do a negative. So make sure that, what we might talk about is leading coefficients, and that's what comes to being negative. So if we were doing negative x to the fourth plus x cubed plus 4. When we say coefficients, that's that negative right there, and that helps us know what our ending behavior is doing as well. So you may hear what's the leading coefficient. If you just notice that it's either negative or positive, that is the most important thing. It could be a negative 4x fourth, it could be negative 1, it doesn't matter. If that's negative, then it flips. So we know that in this case that our ending behavior, as x approaches a positive infinity, it's going to be a negative infinity. And as x approaches negative infinity, y is going to be a negative infinity. Because that's a parabola. Remember, just as a review, this is a parabola like this, but because of that negative, it gets flipped. Now, what is our y-intercept? So our y-intercept for this case, if x is 0, so that's going to make that 0, and what are we left with? We are left with 4. So that means 0, comma 4 is our y-intercept. How many times does it turn? So that's 4 minus 1, so it's 3. We got our end behavior. So now let's just plot the point. 1, 2, 3, 4. It's about right there. And we have to turn 3 times. Again, this doesn't matter where you do it as long as you get there. So 1, 2, 3, and then we go down. Pretty simple. Okay, you try it on your own, see how it works. Again, all you're going to do is you're going to get a graph. You're going to get a polynomial. You're going to sketch the graph. First, you set up your end behavior. Okay, you figure out your y-intercept and then how many turns. That's all you know right now. See how you do.